Imagine this scenario. To those of you that know how to cook, when you're going into the kitchen, you have a jar of salt, you have 2 cups of rice, and you have a drum of water. No offense to those of you that don't know how to cook. Now, when you get to the kitchen, you're going to use 2 cups of rice, but are you going to use the entire jar of salt or the entire drum of water? No, because you only have 2 cups of rice. You're going to take a particular amount of the salt and a particular amount of water that will be enough for the 2 cups of rice. That means that the rice is limited, the salt and the water is in excess, and that's the essence of what we want to talk about. If I have up to 10 cups of rice, then I will probably add more salt and use more water. So that is what we are talking about in this scenario. So that reagents in chemistry too, that you must consider their ratio when they are combining, is what we are trying to talk about. So you cannot just mix things together and feel you want to get product. You must know a particular amount of one thing to add to another thing to give you a particular thing that you want. So let's look at this scenario. Imagine you want to produce a car, and for every car part you require 4 tires. Each car part each car part in this scenario requires 4 tires. Now, that means the ratio you must combine them is for every car part you need 4 tires to give you a whole car. So now, if I have 16 tires and 2 car parts, how many cars will I produce? Which is the limiting and which is in excess? You can see their ratio is 1:4:1. If I have 2 car parts and I have 16 tires, do you think I'm going to use the entire 16 tires? No, because I only have what? Limited car parts. I only have 2 car parts. So I'll be able to produce just 2 cars. I can't produce more than that, because what determines the amount of car we produce is the car part. So now, and the ratio is 1:4:1. So for every car I produce, I need 1 car part and 4 tires. So looking at it, which is limited in this scenario? It is the car part. Which is in excess? It is the tire. The tire is in excess by what amount? By 8 tires. Meaning that if I have 2 other car parts, I can produce more cars. And that is the same scenario we want to talk about. Understanding limiting and excess reagents is important in dealing with stoichiometry problems, because there are some questions you will solve and you will think you have gotten your answers right. If you do not understand limiting and excess reagents, you might have gotten the answer so wrong. So let's look at all these examples and follow through. But before that, you need to write this down. What is limiting reagent? A limiting reagent is a reagent that is limited. That's what it means. That a limiting reagent is the reagent that is used up. So that reagent that is used up at the end of the reaction. What did we use up in the first scenario? The 2 cups of rice. The second scenario, we use the car part. So meaning that those ones are limited. So a limiting reagent is the reagent that is completely used up at the end of the reaction. And this limiting reagents always determine your product. Like I said, what determine the number of cars we produced? The car parts. What determine the amount of rice we produced? The 2 cups of rice. Shey you get? It's not the salt, neither is it the water. It is the 2 cups of rice that determine the amount of rice we produced. If you decide to use the entire salt, well, some of you can do that depending on how you know how to cook. But that 2 cups of rice determine the amount of rice we're going to eventually produce. The reagent that is supplied in abundance is what we call the excess reagent, from the word excess. It means it's too much. So looking at this now, which one do you think is too much in the two scenarios? The tires was much, 16. I only need 8. The salt was much. The drum of water was too much for 2 cups of rice. So that is what we mean by excess reagent. Now you need to understand something. Before you start solving problems using limiting and excess reagents, you must convert those values you have to moles. If your supplied concentration, volume, mass, number of particles, you must convert it to moles before you start solving problems. So let's look at this scenario. Let's look at these questions to deal with them. These are the formulas we have been using. So if this is your first time on the channel, this is the formula we're going to use to solve our questions all through. And we have been using it in the previous classes. So now, looking at these two questions to explain better to you, I would have asked you to try the second one. If you had been solving the questions we have been dealing with the last time, then you should be able to solve the second one. So now let's look at this question. The question said that what is the amount in grams of water produced? What is the amount in grams of water produced when 5 grams of hydrogen and 5 grams of oxygen reacted together? I told you something in the last class. I said, know where you are going, Abby, and know how to get there, right? That was what I told you. So, where am I going here? I want to calculate the amount in grams. What does that mean? Mass of water. So, what do I do first? Write that formula. So, that means that the number of mole of water is going to be mass of water over the molar mass of water. So that's the first scenario. So the second scenario is that how do I get there? I want to get the mass of water. I don't know the number of mole, but I can calculate the molar mass of water. So the molar mass of water, like we did the last time, is going to be 2 into hydrogen plus oxygen, and that's going to be 2 into 1 plus 16, and that's going to be 18 gram per mole. So the molar mass of water is 18 gram per mole. So now that I've gotten the molar mass, I want to calculate mass. So the mass of water is going to be the number of mole of water multiplied by the molar mass. Now, you know the difference between this question and the ones we have been solving before. You were supplied a value for hydrogen and you also supplied a value for oxygen. So before you use them, you must consider, oh, which one is too much, which one is less, which one will determine the amount of water I produce. You know, I told you that it is the limiting reagent that will determine the product. So you have to consider their ratio. How would they combine together? Then look at which one is more and which one is less. That one that is less is the one that will determine your product. So first is to balance the equation now. You know, we want to get the number of mole of water, and from previous classes I told you that we can get the unknown from the known. So now let's look at this. Hydrogen reacts with oxygen to give water. Now if we balance the equation, there are 2 oxygen here, so I can have 2 here, then hydrogen becomes 4. So the ratio is 2 to 1 to 2. I hope you're following. So now whatever hydrogen is, oxygen must be half of it, water will be the same amount. You get? Whatever oxygen is, hydrogen must be twice. If hydrogen is 20, oxygen must be 10, water must also be 20. So we want to use the number of mole of these guys to determine. But the difference here, if you remember the ones we solved in the last class, you were always supplied one. That one you were supplied is what we always use to determine the rest. But in this case now, you were supplied this, you were supplied this. It's like they supplied you the number of cars, just like what I did in the last time, the last slide. They supplied you the number of cars and they also supplied you the number of tires. Now you have to compare what will determine the car. It is the number of car parts, not the number of tires. Because if you want to use 16 tires, that means you must produce 4 cars. But where will you get the remaining 2 car parts? Do you get that? So in that scenario now, the same thing applies here. If I decide to use the entire thing for the one in excess, then I will have a problem with the one that is limited. So let's look at it. I said before you compare their moles, you have to convert whatever you are supplied to moles. Abi, you are supplied the mass of hydrogen and the mass of oxygen. So you will say number of mole of hydrogen. I said you must convert it to the mass of hydrogen over the molar mass of hydrogen. So mass of hydrogen is 5 divided by molar mass of hydrogen gas is 2. That would be 2.5 mole. Do you get that? So that's 2.5 mole. For oxygen, number of mole of oxygen is going to be mass of oxygen over the molar mass of oxygen. And that's going to be 5 over 32. Let me do this one for it. So that's 5 divided by 32. And that's 0.156. 15625 mole. So please write that properly. So 0.15625 mole. So let's compare them. This is 2.5 and this is 0.15625. So if you look at these guys very well, which one do you think is limited? This is where you have to just quickly think about it. Look at this, their ratio must be 2 to 1. If this is 20, this must be 10. If this is 2.5, what do you think this must be? That's like 1.25. So that's going to be 2 2.5 divided by 2. That's 1.25. Is this up to 1.25? No. That means that this is limited, it's not much. So this is what will determine where you are going. There are shortcuts to solving all of these things, but please, I want us to get it right first before we start using shortcuts, because your brain must be able to work, not to always find your way out of everything with easy way out. So now, if this is 2.5 from their ratio, then this must be 1.25. Can you see? But is this up to 1.25? No. But if this is 0.15625, what do you think this should be? That means you're now going to say 0.15625 multiplied by 2. And that will give you 0.3125. So if you look at this now, this is 2 ratio 1. So if this is 0.15625, this will be 0.31. So all you need for this reaction, because of this amount that is available, is this. If you decide to use this, you will need 1.25, but you don't have 1.25, so you have to work with what you have. And that's where the problem is. So you must understand that. So you cannot just say because this is 2.5, then this must also be 2.5. That's going to be wrong. So take your time to understand this. I would like you to practice the second question yourself. I won't solve it for you. If you have been following our classes and what you have been doing, you should be able to. And please, I beg you, always leave your comments at least, or subscribe, leave comments, like the video. Whenever I give assignments, I can see the number of persons watching these videos. So please, let me know if you're following the classes. Let me know what tests you need, and let me know the assignments you are doing, so that it won't just be like a waste of time on our own part. And we are trying to help. We're trying to also promote what the white guys do is no more than this. But most times we promote the white things more because we like the way they probably speak the English and all of those things. And it's let's promote our world too. We're in Nigeria. We have been watching all those Indian guys do a lot of things. We can do a lot too in this country to help ourselves. So please comment. Yes, comment. You, yes, comment. Do the second question. All the previous questions, solve them and leave your comments in it. Let me see difference in this. If you did not get the answers right, then I'll solve it with you. The persons that dropped the answers, I've given them the corrections to it, and they got it right. So, and I have people that have been commenting that they have been finding our videos helpful, and we are trying to do our best. So one or two of these encourage us to do better too. And we encourage you not to give up on your dream too. Irrespective of the challenges we are facing, fight it. You will get it. You will overcome that thing. Medicine, nursing, law, anything you want to do, put your mind to it. You will do it and you will get it. So let's go back to our question. Now, this is 0.15625. This is 0.3125. That's 2 ratio 1. If you check it very well. So what do you think the amount of water will be now? That will also be, because the ratio is 2 to 1 to 2. That will also be 0.3125. Shey you get? If you had said this is 2.5, this is 2.5, then you would have been wrong. So in that case now, hydrogen is in excess, meaning that it's in excess of, if you minus this from this, you will get what it is in excess of. You used the oxygen completely. So that means that the oxygen is limited. And if I've used the entire oxygen, what will the remaining hydrogen react with? Nothing. So take your time, because a lot of people used to mix questions, especially on limiting and excess reagent. So let's get this right. So the moment you get this, the same applies to every other questions. The only thing is just know how to get there. And I think that was what we did in the last class. So you should be able to apply all of those things very well. So now, let's look at it now. We have gotten the number of mole of water and we have the molar mass of water. So now we can say that the mass of water will be equal to that number of mole of water, which is 0.3125 multiplied by molar mass 18. So let's see what that gives us. So 0.3125 multiplied by 18. That is 5.6 grams. So that's 5.625 grams. So that is the mass of water produced. If you had used 2.5, you would have gotten it wrong. But you would have been lucky if you had actually said multiply this by 2. And so just look at that. That is what limiting and excess reagent is all about. What you are supplied versus what you are given. So you were supplied these two. So you have to first compare them before you solve your question. and applying the formulas I gave you in the previous classes. So let's solve this second question. The second question says that calculate the number of molecules of carbon dioxide produced when 10 gram of CaCO3 is treated with 100 cm cube of 0.2 mole per dm cube HCl. In this scenario too, you already know where you are going. Number of molecules. Number of mole is equal to number of particles over Avogadro's constant. So number of molecules will be equal to number of mole times Avogadro's constant. That's the formula you're using. So now, how do I get the number of moles? You already know Avogadro's constant, 6.02 times 10 raised to power 23. So the next question is, how do I get the number of mole of CO2? You will get it from the balanced equation. Add CaCO3 plus HCl. Whenever acid reacts with carbonate, they liberate CO2. So we balance the equation. Now, the difference in this and in the previous question is the same thing as what I just did. Calculate the number of mole of CaCO3 using mass over molar mass. Calculate the number of mole of HCl using concentration times volume divided by 1000. Now compare their mole ratio and calculate the number of molecules of CO2 and leave your answer in the comment section. So let me see if you have gotten this right. If you find this video helpful, please subscribe to our channel, like, encourage us to do better and to do more for you. We want to. And before JAM, we promise that we're going to cover a whole lot of topics for you to enjoy it from the comfort of your home. So please subscribe, and we love you. Share with friends and share with others. God bless you. I'll see you in the next class. In the next class, I'll be talking about molality, normality, all of those things, either percentage yield and things like that that you might need for your post-UTM late journey. But for now, what we have said so far is actually enough for your JAM. There's what we call percentage purity, percentage impurity, and all of those things. By the time you start solving questions, you come across them, and I will still solve a whole lot of questions with you at the end of the entire video. So subscribe and keep on your notification bell, and don't forget, we love you and we're always here with you. Peace out.